This is an introduction to A2 computing for 2014-15. First of all, you can look at the PowerPoint yourself by going and navigating to the F452 room in Moodle, where you'll see a tab here, A2 Fortnight, and then open up the PowerPoint which will introduce the course. I'll just take you through that now. Welcome to a short series of videos designed for A2 Fortnight for computing. The first video will be about A2 computing 2014 to 2015. This small PowerPoint presentation is available on Moodle in the F452 room. Next year, the course comprises of two units, F453 and F454. F453, as you can see, is worth 30% of the whole entire course, and F454 is 20% of the course. This is because it is a 2-hour exam with 120 questions for F453, and the coursework is worth 80 marks. It is worth really working hard on the coursework, because most of the students who do the coursework from September through to December, when they get the results, 80% of students would have known that they've passed the course already, having gained their marks. Next year, I'm going to be the A2 teacher unless there's two classes. We haven't decided who the second teacher is. It will probably be, I probably either take both classes, or Paul Weirmouth will probably take the second class. F454, basically it has to be handed in by Friday the 12th of December 2014. It's worth 80 marks, and it is a substantial piece of project work. You must make all the deadlines or you lose marks, and it's basically broken into 5 sections. First one, definition, you're going to be doing as summer homework, and then investigation analysis is bolted onto that, and that will be worth 14 marks. There will be plenty of guidance at the start and throughout the process, but it's really dependent on having a client. Design is the next section. That's worth 16 marks. Mostly that will be fixed in with prototyping, and you will have to show that you have designed your product with the aid of your client or user. Then you come on to software development. That's actually coding. At that particular point, you'll be coding and testing throughout, although there's 20 marks for the actual coding itself and its code comments, and then testing is an extra 10 marks at the end. Documentation is a simple section to pick up marks. You're not going to write anything substantial. All you're going to do is have a small 3 or 4 page guide, mostly pictures, telling typical use, and also things like technical support and security. And you'll also be expected to put help sections in your software, whether it be a game, a business product, or an education package or something else. The evaluation is very important at the end. This is why you need a good client, because you will have to have feedback from the client, quite substantial, and they will have to rate whether or not your software can be used immediately, or whether it still needs some work. You will also critically evaluate your system and talk about how you would extend it in the future. The program itself should be substantial. If you can write the program within a couple of weeks, then it's not suitable for an A-level project. Suggestions are that you use C# form application using an Access database. Some people have used MySQL. Other languages must be agreed with the teacher, and you must already be a programmer in that language, and I will set you a task in order for you to prove to me that you can actually write something substantial in that language. Unit F453, Advanced Computer Theory. The exam for that is on the 23rd of June 2015, and it's, like I said, 120 marked written exam. You will cover the functions of an operating system. This is usually done at the end. It's the last one that we teach because it encompasses lots of the other sections in it. We'll look at the function and purpose of translators. That's translating any language, whether it's C#, machine or assembly language or other languages, either assemble it, compile it, or translate it into binary for the native machine. Computer architecture is an extension of what you did about registers, CPU and buses, but this time we'll be put it into context using actual programming language or assembly language, and you'll be using a central processor unit simulator, and you'll be able to see how the code and the registers are used, and you'll be introduced to a couple of new registers too. Data representation for all you maths fans won't be basically as big a section. You're only going to deal with one topic, and that's floating point numbers. That means binary with a decimal point. Data structures and data manipulation. We're going to look at, you've already covered record structures and arrays, but we're going to look at dynamic data types and also ways of manipulating data to make you a better programmer. So we'll look at queues and stacks and other sort and search routines. High-level language program paradigms is probably one of the most popular sections of the A2 course because we cover object-oriented programming and Prolog artificial intelligence language, and in that you will learn how modern programming is done and how things like Visual Studios really can open up the world of programming. Programming techniques really ties together a lot of the programming you've done and adds more techniques to make you a better programmer. Low-level languages is also a good section, being that you learn to program in assembly language and machine code, and we've got a simulator, like I said, to do that, so you'll actually get some experience. Programmers still program in low-level languages when they design operating systems or hardware devices. Databases is unlike ICT or anything you've probably done at school. We don't use packages such as Access or other databases. We code a database using C# and SQL. And you will learn also to normalize a database, and that means make data the center of how databases are designed and make sure that it's correctly divided up and used. So you need to start thinking about a project now. Look at this slide and look at the ideas that are on it. You've got everything from revised versions of retro games right down to sport, scoring and statistical systems. I've had a multitude of different projects presented over many years, and this list is also not exhaustive, so you can actually come to me with an idea, and the teachers will be coming to you all through the week and discussing ideas for potential projects with you. You can always email me as well at sregan@qeliz.ac.uk if you want to discuss ideas with me. So, is your project suitable? Basically, is it a real situation can be investigated? That means you're going to have to do analysis investigation, so it has to be something that's already existing or you can improve on it. If it's a brand new idea, then there must have been some other process, maybe not on computers, that you can investigate to show a need to computerize it. Is there a real or potential user whose needs can be investigated and taken into account when designing solution? The lowest project marks we get are for those people that do not interact with a user or a client whilst designing their software. If it's not user-centered, then you can't gain any more than about half the marks. So you must have a realistic user, and that can be anybody over 21 who has an interest or an idea in what you're developing and will give you good feedback. Does it conform to the syllabus requirements? Will the finished project be a tailored solution and which allows interaction between the user, computer, input data, process data and output? That's the old input, process, output, and I would add storage part. If your project encompasses all four of those, then it's potentially a good project. Is it advanced level standard? It's no good doing something you could do in a couple of weeks. It has to be a substantial piece of code. Is it within your capability to complete in a reasonable amount of time? A lot of you will be underconfident and think that you can't program to a standard required. That's not true. I had a student last year who came in and failed his F452 but passed his theory and managed to get a B on the project, because a lot of the project is not about coding. So that bit, when he came to coding, he managed to do something within his capabilities that was good enough and picked up much of the marks from the design, analysis and evaluation. Are the necessary facilities ready and available to you? If you're going to be ambitious and do something which requires equipment or other facilities, then make sure that you can have access throughout your project to them. Is it a subject you have knowledge or interest of? It is a long project, and a lot of students have come to me halfway through it saying that they wish they picked something else. So please pick something that can have a good client, is of interest to you, and one that you can follow through to the end. Unless the answer to all the questions above is yes, then I would think again when you come to do the project. The summer assignment homework will be given to you in the second to last lesson of A2 fortnight. You must do it. Basically, if you don't, your place will be in jeopardy. It will be a task to actually bring up a definition, a project definition, and have a meeting with a potential user and a client. You will hand it in the first day back. There will also be the code for Space Invaders to give you more practice in actually coding. Although all the code will be there, you'll be able to look at the various techniques that have been introduced to you in A2 week. This is a lesson breakdown for the week. I would look at it and study it. It doesn't mean that it's got to exactly follow this pattern, but this is all the objectives that we hope to cover during the week. Any that aren't covered will be available on Moodle for self-study, and there should be a video with each one of them by the end of A2 week.